And that kind of leads me into validity issues that we have when we're talking about experimental design. There's two sources of invalidity. Something that's not valid again. There's a thing called, is the research internally valid and is it externally valid? So internally valid, internal validity, did the treatments or the independent variable really cause the change in the outcomes, which is the dependent variable? Any problems with internal validity have to do with the design and or methods flaws. If you design the research improperly, you can have some real problems with the internal validity. The independent variable really didn't cause any change on a dependent variable because you have some issues with the internal validity. And again, we identified this within the limitations of our chapter 1. That's what the limitations of a study are. It's their weaknesses. What's wrong with the design of the study? Now, the other kind of other validity issue is called external validity. And what external validity is, can you generalize or can you take the results of the final study findings? Can you really say that the results of that study from that study's subjects, can you generalize the information back to the population? If we did a study on, I'm going to use athletic training students, say we had 250 athletic training students, we did some kind of study on them, can we really take the results back to all athletic training students? Some of these issues are non-design and or method flaws. If we don't design our study correctly, the internal validity part, then it's going to end up having external validity issues. That's one of the reasons why I've asked you to look at the weaknesses or the limitations of research studies. That's what I was talking about, and you guys did a pretty good job with not having all that information yet on identifying some of the weaknesses in studies. Now we're going to talk about specific threats to internal validity. The textbook does a pretty decent job on going over these different threats. And in your learning activity, you're going to have to identify these, so you're going to become familiar with these. So I think we got about 9 of these. Our first one, and these aren't in any particular order of importance here. So the first one's called history, and we have events that are not part of the treatment. And so in the book it says, in a study evaluating the effects of a semester of physical education on the physical fitness of 5th graders, the fact that 60% of the children participated in a recreational soccer program will constitute a history threat to internal validity. So it's things outside of your experiment that have nothing to do with the treatment or the experiment. So it's other issues. Say you set up a fitness program, and just like the example in the book, they're only supposed to do your fitness program, but they turn around and says, well, I want to work out more. So you have some people that work out more. That's part of the history. That's a threat to the internal validity. Another threat is maturation. This is really critical with kids, because let's say you do a exercise program, you start at the beginning of the year and you're going to track them through the whole year. Say we're doing like 4th graders, and we want to do a test at the beginning, and we do tests throughout the year towards the end of the year. Well, the kids are going to mature naturally, and they're going to learn, they're going to get stronger. So maturation is a big issue with that. Another threat is testing, the effects of more than just one test. In a lot of these designs, you'll see we do a pre-test and a post-test, or multiple different tests. Well, that's going to have effect because people may learn how to do better on the test. So that's a threat. The next threat is called instrumentation. And the instrument, we've talked about the reliability and validity. That reliability is the ability of the instrument to measure the same thing repeatedly over and over. And validity is, does it actually measure what it's supposed to measure? And so sometimes there can be lack of instrument validity and reliability. That's one of the reasons why you have to report the instrument validity and reliability in Chapter 3. And it also can be people may change over time. The people are actually doing the test. The calibration may change over time. Another threat is statistical regression. I call this regression towards the mean. That means you can keep doing the test over and over again. People are going to start going back towards the means, because we know the bell-shaped curve, and most people are in the mean. And then if we select individuals that are on either side of the extreme on scores, extremely low or extremely high in a score, they're probably going to go back towards the middle over time. Statistically, we know that. The next threat is selection bias. Selection bias is when we don't randomly select our participant. Now, let me give you some other terms that you've got to be familiar with. One is, we talked about before, is random selection, whereas we have our population and we want to randomly select our target or our subjects so everybody has equal chance to be in the study. Random selection. Then another one is random assignment to groups, where after we've randomly selected our groups, let's say we have 3 groups in our study, we randomly assign those members into groups so they're all equal to one another. Well, if we have selection bias, that means we have non-random participation selection. And sometimes that's just something we have to do. That means we select our participants by convenience, or all the other forms of non-random selection that we talked about in the past. Experimental mortality. That means that we lose subjects. We've set up our 12-week experiment, and during that 12 weeks we lose 1 or 2 of our subjects. There's not much we can do about that. Selection maturation interaction is our next threat to internal validity. And what the book does a pretty decent job here describing this. Selection maturation interaction is the passage of time influencing groups differently. One group is selected because some specific characteristics, whereas another group lacks this characteristics. And so the book is an example, a study. There's a study of the differences between 6-year-olds in 2 school districts. Students in one school district from the experimental group receives a fitness program, and the students in the other are a control group. If the school districts have different admission policies, so that the 6-year-olds in experimental group are 5 months older, it will be difficult to determine whether the fitness program or the fitness program combined with participants of that age produced observed changes. So got to look at who's in your group. Are they really equal? Are they similar groups or similar subjects? The next threat is expectancy. This is the influence of experimenters on the participants. The researcher or the experimenter themselves may expect the experimental group to do better than the control group, so they may actually rate them differently than the control group. So there's some bias going on there. So we talked about threats to internal validity. Let's talk about threats to external validity. And we have 4 of these. Again, threats to external validity can you take the results from your study and take it back to the population? Can you really say that the results from your study can be really given back to the general population or the population of your study? So, reactive or interactive effects of testing. If you give pretest, we've talked about this in internal validity, so it kind of goes back to this too. The pretest may make the participants sensitive to the treatment. They may, since they did the pretest, they already may know what's coming and they've learned how to do the test. So that's one threat to external validity. The interaction of selection bias and treatment. The treatment may work only on participants selected on specific characteristics. In the book, they give a pretty good example of in this. For example, a drug education program might be effective in changing attitudes of college freshmen towards drug use, but this program probably not going to have an effect on the third-year medical students. They're two different groups, so really you can only give that results to specific groups of individuals. You can't make it real general to the whole world, the whole population. It has to be specific to a group. Reactive effects of experimental arrangements. The setting constraints may influence generalizability. For example, if the study was done in a laboratory, you really shouldn't be able to generalize the results of that study back to non-laboratory settings. And that worked in a laboratory, but how well will it really work in a baseball field or a basketball court? So that's for example. Multiple treatment interference is the next threat to internal validity. One treatment may influence the next treatment. So if we have a study where you have multiple treatments, multiple experiments going on with the group, they may interfere with the effect of the outcome, the total outcome at the end. Then that result may not be very generalizable back to any population at all. So we need to control threats to internal and external validity. And so we're going to talk about the steps how to control threats to internal and external validity. The first one, the big one, is really internal, because that's where we really have all the control. If we control the issues in internal validity, and most of the time it's going to control our external validity issues. And again, where we identify the weaknesses in our study, where we know we have limitations or we have threats to our internal validity, is in our Chapter 1 and the limitations section. Okay, so the main way that we control internal validity is in a randomization, which is, again, we do random selection of our subjects, and we do random assignment of our subjects to groups. That is the best way for us to control internal validity issues. And a lot of times that's kind of hard to do in our area. So, and again, what they mean by real randomization is that everybody has equal chance to be in a study. Another type of randomization is called match pairs, not match groups. This is where we assign participants based on particular characteristics. For example, we can assign participants based on gender, experimental level, grade level, those type of things. The other critical thing is that we want to have equal numbers of participants with that characteristic in the experimental and the control group. As a reminder, the number that we probably want in each one of our groups is about 30. We want to have about 30 subjects in each groups. So if we have a study with 3 different groups, we need to have a total of 90 subjects with 30 subjects in each group. The other way that we control internal validity issues is by using a placebo effect. Now, the placebo effect, a control group the placebo is when the control group receives a fake treatment where they think they are getting a treatment. At the same time, the experimental group is getting a real treatment. We've heard of placebos, you know, salt pills or whatever, or sugar pills. You think you're getting something, but you're really not. And so both groups or three groups or whatever, everybody thinks they're getting the same treatment, but one group of people is really not getting a treatment, but they think they are. So that's a placebo. A blind setup is when the participants don't know whether they are part of the experimental group or if they are receiving, excuse me, they don't know if they are getting the real treatment or a fake treatment, or if they are in the experimental or control group. And a double-blind setup is where the participants or the experimenters don't know which treatment everybody's getting. So the experimenter, the researcher, and the participants don't know which treatment they are receiving, if it's real or not. Some uncontrolled threats to internal validity is reactive effects of testing. Again, we talked about that. You know, effective testing is that they get a pre-test and they learn, and so on their post-test they've learned something. The only way to get rid of that is you got to eliminate the pre-test. And some designs that's not the best way to do it. Some designs it's best to have the pre and post-test. Other things that we can't control is the instrumentation. We can, to a point. We have, if we have good, reliable instruments, if the calibration goes out of whack, sometimes we can't do much about that. If our scale, through the time of passage of time with our study, our weight scale gets out of calibration, unless we're calibrating every single time, that's the only way we can control that. Other things called halo effect, where the person who is actually giving, or might be rating, say you're doing some kind of observational rating score test, the researcher or the observer may actually rate the beginning people and the last people differently over time. They either get closer to one another or further apart, so they change the way they rate the people. And the last one is experimental mortality or subject mortality. That's where people drop off and you can't do nothing about that. You've got to try to keep your participants engaged as many ways as you can. Now, to control threats to external validity, the things to do with that is get your population, your subjects, from the large population as possible. You want to select from the largest population. Your participants, your treatments, and your situations all need to be randomly selected. It's about the only thing you can do. Another terminology that's in the textbook is called ecological validity. Does the setting capture the essence of the real world? What that means is, did your study, was it like the real world? Was it in a lab? You want to try to make the experiment as close to the real life setting as possible. So you have to get as close as you possibly can.